So now we're going to get into some of the numerical values when it comes to statistics that you normally think about with statistics. We're going to start off with measures of center, which we're going to look at mean, median, and mode primarily. When you see mean, you should think about your typical average. Add them all up, divide by however many there are. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15 data points. And so we're going to add up all 15 of them and then divide by the number 15. Now, this isn't the most efficient way of going about it, but we could definitely do this. We could get out our calculator. Oops, let me exit out of here. We could get out our calculator and say, let me make a fraction, and let me add 10 plus 27 plus 47 plus 61 plus 83 plus 92. Really boring here. Plus 14 plus 53 plus 56 plus 93 plus 57 plus 19 plus 96 plus 65 plus 95. Whew. And then arrow down to the bottom and say, let's divide that all by 15. And we get this number here. We can turn it into a decimal if we want. And we get this number about 57.9 or so. Now, when we're doing mean, we should be able to look at this and say, hey, does that make sense if we look at this data here? It went from 10 all the way up to 96. And so if we just do a ballpark figure of there and figure out what's halfway between 10 and 96, well, let's do that. What is halfway between 10 and 96? Let's add them together and just divide by 2. 53. 53 is halfway between 10 and 96. This is what's called the mid-range. This gives an idea to say, yeah, it looks like 57.9 is probably good because there's more big numbers in this data set than there were small numbers. So this answer makes sense. Now let's look at median. Median should mean to you the middle number in the data set. So the average took into account how much bigger each one was. But when it comes to median, you're just looking for whatever number happens to be in the middle. In order to find the median, what you got to do is first order your data set. Get it in order from smallest to largest. So for this first data set, we want to rewrite it as 4, 5, 7, 9, 12. For the second data set, we would rewrite it as 3, 7, 9, 15. Now, as we look at these two data sets, we got to figure out where the middle is. Now, I gave you a very small data set so that it's fairly easy to see that. You can probably see the 7 is in the middle of this first one, and that is, in fact, the median. Now, we could actually kind of use a formula to figure out roughly which number the median is. And we can use this simple data set to figure it out. Because it might seem like if we were to look at this and say, how many data points are there? There's 5. What's half of that? Well, that's 2.5. That doesn't really tell me a whole lot. We know that the answer that we're looking for here, if I want to figure out where's the median at, it should be the third data point. We can see that very easily by looking at this simple data set. So what we could actually do is if I did 5 plus 1 divided by 2, that's the third data point. So if there's an odd number of data points in your set, then you can take the number of data points plus 1 and divide by 2, and this is the place of the median. And by place, I mean it's the third. Now, if we want to find the median of the second data set, this is a little bit trickier because if we just visually look for the middle, it looks like it's between the 7 and the 9. And that is actually what we would do. So when you have an even number, you find your two middle values and you take their average. So we add them together and divide by 2. And so 8 would actually be the median, even though 8's not one of the data points. So you could theoretically have a data set that's all whole numbers and end up with a decimal value for a median. Because, for instance, if instead of 7 and 9, those were 7 and 8, then our middle value would have been 7.5. And so if there's an even number, then we're going to take the average of n over 2 and n over 2 plus 1. And so what I mean by this is in this case, there were 4 data points. We want to take the average of the second and the third data point. And that by average, I do, of course, mean mean in this case. So we just add them together and divide by 2, and that's how we find the median. Now, for a lot of cases, mode is not the most helpful measure of center, and it's not really even a measure of center so much as it just kind of goes along with mean and median because it starts with an M too. But mode talks about the most frequently occurring value in your data set. Mode is very helpful for what we call nominal data that's not really numbers, to see which item came up the most frequently. So that, for instance, if we were looking at what country won the gold medal in hockey, our data set wouldn't be numbers. Our data set would be Canada, USA, Russia, all these different countries. And then we could look at the mode and say which one came up the most frequently. And so did Canada come up the most frequently? They've won the most gold medals in hockey. So that's what we could look at for mode. But we can look at numerically as well. So in this data set, if I want to find the mode, I would start off at the beginning and say, let me look at 56. Are there any other 56s? Nope, there's only one. So then I look at 37. And say, hey, do I see any other 37s? Nope, there's only one. How about 29s? Oh, there actually are a couple 29s. There's 1, 2, 3. So that's going to be a good option for our mode. I'm just going to cross off the other ones. Remember, I've already seen them. And I look at 79. So, it looks like there's 2 79s. And how about 47? I only see the one 47. 57, I only see the one of him. 39, there's only one of. 31, 36 are each ones. And so we can see fairly quickly that 29 is the most frequently occurring value. Now, when I did that first mean example, that was a lot to type into the calculator. And then if I wanted to find something else with that data set, I'd have to retype a whole other formula. So it's actually really handy to be able to use your calculator to find mean and some of these other values. And we can do that in our calculator with some of the techniques we've used previously, like the data. So I have some old stuff in here. I'm going to go to my clear all function and clear it out of there. But we can go ahead and type in these data points. So we can type in the 10, 27. So we still got to type in that sense, so it's still a little bit time consuming to type in all these values. But once we do that, we can get a whole lot of stuff out of it. So I'm getting there. At the end of the first column, now we're going into the 56, 93, 57, 19, 96, 65, we're almost there, and 95. Now that we're there, the thing that we want to go to is hitting second in data, which gets us to stats, and we've used this before. Go to one variable stats, but now it's really important because we have used this before. When we are doing expected values, we want to make sure that our frequency is set back to 1 because we don't actually have a frequency set up in our L2 column. So we want to tell the calculator that L1 has our data and the frequency is there's one of each of them. And I hit calc, and this gives me a lot of information. So I want to jot down real quick, and you should jot this down in your notes, that the x with a bar over it, that's the mean. So this gets us that 57.9 value that we found earlier. But then if we scroll down here using the arrow down, we're going to talk about that Sx in a moment. This sigma x is the sum of all the x values. There's the sum of all the squared. There's my smallest value is a 10. But here we go. Median. So the median right there, after we scroll down a bit, is given to us as well. It's denoted capital MED, but that's the median, and that's 57 for this data set. Now, if we scroll down, it also gives us the max value, the largest value, which is 96. So that's kind of handy as well, that it can give us both the max and the min. Now let's talk about taking the mean and the median and the mode of a frequency distribution. So I want to point out, first of all, that with this frequency distribution, what this means is that my data set looks like 20, 21, 20, I wrote 22. Why did I do that? 21, 21, 21, 21. That's what that frequency of 4 means. And there's 3 22s. And there's 4 23s. And there's 8 24s. There's a whole bunch of 24s. So that's what this means. This data set is not just 20, 21, 22, 23, 24. There's a 20, but there's a bunch of 21s, a bunch of 22s, a bunch of 23s, a ton of 24s. So instead of writing all that out and putting all of that into the calculator to try to find the mean and the median, and possibly the mode, we can go and use some of the features that we've used before. I'm going to clear this out, but we can go ahead and type in just exactly as it appears this frequency distribution. We can put in the x values, and then we can arrow over and put the frequencies into the second column, where we have 1, 4, 3, 4, and 8. So that then when we go to our one variable statistics, we can tell the calculator, hey, my frequencies for this frequency distribution are in the second column. And then I can hit enter on the calc, and it's going to tell me my mean. My mean's 22.7 according to this. And if I scroll down, I can get the median as well. And the median's 23. Now the calculator doesn't tell us the mode, but it's easy enough to look at this and see what the mode is. The mode is the most frequently occurring data point. There's 8 24s. There's 4 23s. There's 3 22s. The one that occurs the most is the 24. There's 8 of them. So it's actually really easy to see with a frequency distribution what your mode is. Now, if we didn't use the calculator trick, basically we would have had to write it out like I had it and add up all these. We'd have to add up 20 plus 21 plus 21 plus 21 plus 21 plus 22 plus 22 plus 22 plus 22 plus 23 plus 23 plus 23 plus 23, etc. Or we could have used a little bit of a trick. Instead, if I multiply these together, then when I divide by how many I have by adding up all the frequencies. That's what we did when taking weighted averages by hand and expected value by hand. I didn't call it this at the time, but we are taking the mean of a frequency distribution. But we can use the calculator to do it anyhow. That's a little bit easier.